Monsoon is traditionally defined as a seasonal reversing wind accompanied by corresponding changes in precipitation, but is now used to describe seasonal changes in atmospheric circulation and precipitation associated with the asymmetric heating of land and sea. Monsoons are large-scale sea breezes that occur when the temperature on land is significantly warmer or cooler than the temperature of the ocean. These temperature imbalances happen because oceans and land absorb heat in different ways. Over oceans, the air temperature remains relatively stable. There are two reasons for this: because water has a relatively high heat capacity, and because both conduction and convection will equilibrate a hot or cold surface with deeper water. Oppositely, dirt, sand, and rocks have lower heat capacities, and they can only transmit heat into the earth by conduction and not by convection. Therefore, bodies of water stay at a more even temperature, while land tends to vary in temperature. During warmer months, sunlight heats both land and ocean surfaces, but land temperatures rise more quickly. As the land's surface becomes warmer, the air above it expands and an area of low pressure develops. Meanwhile, the ocean remains at a lower temperature than the land, so the air above it retains a higher pressure. This difference in pressure causes sea breezes to blow from the ocean to the land, bringing moist air inland. This moist air rises to a higher altitude over land and then it flows back toward the ocean, completing the cycle. However, the air cools when it rises and while it is still over the land. This decreases the air's ability to hold water, causing precipitation over the land. In the colder months, the cycle is reversed. Then the land cools faster than the oceans, and the air over the land has higher pressure than the air over the ocean. This causes the air over the land to flow to the ocean. When humid air rises over the ocean, it cools, and this causes precipitation over the oceans. So how does a monsoon wind system form over India? The Thar Desert and adjoining areas of the northern and central Indian subcontinent heats up considerably during the hot summers, causing a low-pressure area over the northern and central Indian subcontinent. To fill this void, the moisture-laden winds from the Indian Ocean rush into the subcontinent. These winds, rich in moisture, are drawn towards the Himalayas. The Himalayas then act like a high wall, blocking the winds from passing into Central Asia and forcing them to rise. As the clouds rise, their temperature drops and precipitation occurs.